Okay, we're on to solving exponential and log equations today. The unit's going by pretty quickly, so again, if you are lost on any topics with logs or even exponents, you need to come see me either during class or after school. So today we're going to do a little bit first with exponentials, and then we're going to go into log equations. In the previous chapter, if you can remember, when we were solving log equations, if we didn't have a common base, we tried to find a common base. So once we had the common base, we could drop the bases and set the exponents equal to each other and solve. Well, it's kind of the same thing here, but we're looking now when we can't find the common base. And when we can't find a common base, they want us to actually take the log of each side. So we're basically going to give each side a log. And then rewrite using the power rule and solve for the variable. So let's try that. Solve 7 raised to the x power equals 83 for x to the nearest 10,000. 10,000 means we're going to need our calculator. If you don't have it, pause the video, go get it, and come back so that we can all work on the calculator while we're solving this problem. Alright, now that you got your calculator, there's no way I'm going to be able to find a common base for 7 and 83. So I can't solve this the way I'm used to. So I'm going to solve it the new way. I'm going to give each side a log. So I'm going to have log of 7x equals log of 83. I'm actually going to do the power rule, bring the exponent to the front. I want x by itself, so I'm going to get rid of a multiplying log of 7 by dividing log of 7. Now, I can put this in the calculator because there isn't no base given, which means it's base 10. And base 10 is the calculator. So I'm going to get x on the left side equals log of 83 divided by log of 7 on the calculator. Please remember we need our answer to the nearest 10,000. And hopefully you got 2.2708. All right, let's go on to the next example. This next example wants us to solve for x. But in this case, it looks like I can do a solve using an exponential rule. I can get rid of the exponent by raising to the reciprocal power. All right, so let's do that. I'm going to have x to the 5.2 power raised to the 1 over 5.2 equals 112 raised to the 1 over 5.2. 5.2 raised to the 1 over 5.2 is 1. X to the first is x. 112 raised to the 1 over 5.2. So you're going to put in your calculator as 112, caret, parentheses 1 divided by 5.2, close parentheses, enter. And hopefully to the nearest tenth, you're going to end up with 2.5. So that was an easy solve. So we just reviewed how to solve exponentially and what happens when we can't find a common base. Well, we give it a common log now. Now we're going to go into actually solving log equations. Basically, when you're solving log equations, you want to get a single log equal to a single log. So in order to do that, you first have to make sure you have common bases, because if you don't have common bases, you can't apply any of the rules. But if you have common bases, you can apply the properties of logs to get it down to a single log, and once you have a single log equal to a single log, you can actually cross out the logs and set the remainder of the equation equal to each other and solve. Alright, that's a mouthful. So let's go over that by actually doing one. First thing, let's check. Do we have a common base? Yes, we do on both sides. So I've got to get the left side down to a single log. It's addition, and in the world of logs, addition means multiplication. So we're going to write it as log base b of 3x equals log base b. Oops, let's make that b a little smaller because it's a subscript of 12. Alright, I have a single log equal to a single log, and they both have common bases, so I can eliminate the logs. And now I have 3x equals 12, divide each side by 3, x is 4, and there's your answer. Alright, let's take a look at number 4 then. They have a common base, so we're going to try to get the left side down to a single log. The 2 in front means it was an exponent, and addition means multiplication. So we're going to have log base 3 of 9 squared times x equals log base 3 of 27. All right, 9 squared is 81, so we have log base 3 of 81x equals log base 3 of 27. All right, we've got it down to a single log equal to a single log, which they have common bases, so I can actually eliminate the logs. And now I have 81x equals 27. Divide each side by 81. Please remember you can't have a long decimal, a non-repeating decimal, or a repeating decimal, so if you do, try to go math, fraction, enter. And in this case, hopefully you got 1/3 as an answer. All right, I want you to circle number 5 because number 5 I'd like you to do on your own after the video, and then we'll look at that one in class tomorrow. Number 6 and 7, I'd like you to do the same thing when we're done with the video, complete them, and we'll go over them tomorrow. Now on to number 8. All right, we have multiple logs on the left side, so let's get it down to a single log. So we'll have log of, addition means multiplication, so log of x minus 1 times 2x minus 3 equals 1. I'm going to do FOIL, first, outer, inner, last combined like terms. I'm going to have log of 2x squared minus 5x plus 3 equals 1. I can't drop the log because I don't have a log on the other side of the equation. Let's see here. I can't give the other side a log because when you give a log, you have to give it to both sides, and the left already has a log. But I have an answer, so I can change it to an exponential. But wait a minute, do I have a base? You're right, I do have a base. If it's not there, it's understood to be base 10. So if I change it to an exponential, it's going to be 10 to the first power equals 2x squared minus 5x plus 3. 10 to the first power is 10, so 10 equals 2x squared minus 5x plus 3. I'm going to subtract 10 on both sides. 0 equals 2x squared minus 5x minus 7. It's a trial and error, so I'm going to go off to the side. I'm going to multiply the first and last term, which I'm going to get a negative 14. I need factors of a negative 14. That'll give me, let's see here, a negative 5. You're right, it's going to be a negative 7 and a positive 2. So that's what I'm going to have. 0 equals 2x squared minus 7x plus 2x minus 7. I'm going to do grouping. I can't GCF anything out of the beginning one. Oh yeah, I can. I can GCF out an x, so I'm going to get x, and then I'll get 2x minus 7. I'll GCF, a positive 1 this time, and get 2x minus 7. So I'm going to end up with 0 equals x plus 1 times 2x minus 7. I'm going to t-bar. I'm going to get x equals a negative 1 on the left, and on the right I'm going to get x equals, let's see, if I add the 7 and divide by 2, 7/2. Okay, if I actually put the negative 1 into the equation, I'm going to end up with a negative, and I can't have the log of a negative number, so I'm going to reject this. I'm going to check 7/2 in my calculator because it is log base 10. So I'm going to go log of, parentheses again, 7 divided by 2, close parentheses, minus 1, close parentheses, plus, log of, parentheses, 2 times 7/2 minus 3, close parentheses, enter, and guess what? You get 1. So my answer is x equals 7/2. Okay, let's move on to example number 9 now. All right, I've got logs on both sides this time, which makes it a lot easier. They have a common base, so if I can get a single log on the left, then maybe I can solve. All right, half means in the front that it was an exponent, but raising to the half power means, oh, you're right, square rooting. So let's see what we have here. We'll have log base 4 of, and adding means multiplication, and 6 times 24 is 144. So it's the square root of 144 equals log base 4 of x. I'm going to actually drop or cancel the logs and get square root of 144 equals x. 12 equals x. Wow, that was an easy solve. And I actually can check it if I do everything by change of base, but to save a little time, I'm going to tell you it's going to work. All right, let's take a look at our very last example today. Number 10. Solve for x. I have logs only on one side of the equation, so I'm actually going to get it down to a single log. So log base 2 of addition means multiplication. X squared minus 4x equals 5. Alright, I don't have a log on the right side, so I can't drop logs. I can't give them a common log because I already have a log. Oh, I've got an answer, so I got to change it to an exponential. So my base is 2. So it's going to be 2 to the 5th equals x squared minus 4x. 2 to the 5th is 32 equals x squared minus 4x. Subtract 32 on both sides. X squared minus 4x minus 32. Can't GCF, and it's an easy 2 binomial. It's an x and an x, minus 8 and a positive 4. T-bar, I get x equals 8 and x equals a negative 4. If I actually checked it and plugged it in, I'm going to have to reject the negative 4 right away, because if I put negative 4 in here, it's taking, or even in here, it's taking the log of a negative number, so it won't work. So I can do change of base to both sides and add them and see if I get 5, and I do. Tomorrow in class, if you don't understand how to check using change of base, we'll go over that tomorrow. Just don't forget to ask me. Alright, so that is how we solve exponential equations and log equations. See you in class tomorrow.